Okay, so let's start. We are starting with work energy power. Haven't received. Yeah, I know because I forgot to make the link for the class. That's why you guys didn't receive the email. But hopefully next time you will. Okay. So we're doing work energy power. Now, what have we done so far? We have basically understood the difference between work done by and work done against. So by is when the object is moving in the same direction as the force. Okay, so we say work done by the force. But when the object is moving against the direction in which the force is acting, which could be the weight, which could be the friction, which could be the resistance, we say that the work is done against gravity. The work is done against friction. The work is done against resistance. Okay. So that's the difference. If it's by, if the object is moving down, we say that the work is done by the weight. No, in fact, मैंने एक लिखा था ना यहाँ पे हाँ. By means that the object is moving in the same direction as the force. Against is when the object is moving in the opposite direction as the force. Okay, so let's solve some questions. So we're going to increase the difficulty level a little. And here it is. Let's solve these questions. Let's see what this says. A box of mass 5 kg is pushed up a slope inclined to 30 degrees to the horizontal by a force of 30 newtons at an angle of 10 degrees to the slope. The frictional force acting on the box is 2 newtons. The box moves a distance of 3 meters up the slope. Find the work done against friction. Okay, find the work done against friction. So if you're supposed to find out the work that is done against friction, you're going to take the frictional force and multiply it by the distance. And what are you going to make sure of? You're going to make sure of the fact that the two values are in the same direction, meaning the force that you're taking and whatever it is that you're multiplying it with, they're both in the same direction. So where's the friction force? Here's the friction force, and the box is moving 3 meters up the slope. So that means work done, as we know, is equals to force times distance, except here we're going to talk about the frictional force multiplied by the distance. What's the frictional force? That's 2. What's the distance? That's 3. So that means the work done against friction. And once again, why is the word against? Why is it that the word over here used is the word against? Because the object is moving. Sorry, it's not newtons. It's going to be in joules. Because the object is moving in the opposite direction to the frictional force. Okay, I repeat, this is the direction in which the frictional force is acting. This is the direction in which the object is moving. That is why the word that is used is the word against. Okay, so I'll make a diagram of it here also. So this is the object. It moves a distance of 3 meters. So it's here. And the frictional force was acting in this direction. It was 2 newtons. The object has moved 3 meters. So therefore, the work has been done against the friction. And that's equal to 6 meters. Okay. Now part B. In part B, we're supposed to find out the work done against gravity. So how do you find out the work done against gravity? To find out the work done against gravity, we will take the weight multiplied by the distance that it moves. Okay, and remember, the work done against gravity, I think we wrote it down earlier as well. The work that is done against gravity is basically the increase in GPE, gravitational potential energy. Okay, so remember this, that the work that is done against gravity is basically the same as the increase in gravitational potential energy or the change in potential energy. Okay, so let's see what we can do. If I want to find out the work that is done against gravity, we need to find out the weight, which we already have. We need to multiply that by the height. Now, do we have the height? No, we don't. We don't have the height, so we need to figure out the height. So here is the object. It moves here. The distance that it moves is 3 meters. Okay, so the distance that it moves is 3 meters up the slope, but obviously that can't be the height. We need to work out the height. How will we work out the height? Let's find out. This is the height that we want. Okay, now do we have enough information to figure it out? Let's see. So this is 30 degrees. So that means the height would be equal to 3 sine 30. That is what the height is equal to. Okay. And what about the weight? The weight, the mass of the object is 5 kg. That means the weight is equal to 50 newtons. So the work done against gravity is the force multiplied by the distance. The force is 50 multiplied by 3 sine 30. What's that equal to? 3 sine 30. Sine 30 is half. So that means 50 into 3 upon 2. So that's 75 joules. Now, any questions so far? If yes, please let me know. यहाँ तक से कोई मसला है तो प्लीज बताएं. Okay, now let's do part C. Part C says find the work done by the push force. So the work done, now notice the word over here is by. Why is the word by over here and in the previous the word was against? Because in the previous question, notice that the force was acting in one direction and the object was moving in the opposite direction. Okay, so because the object was moving in the opposite direction as the force, the word was used against. Okay, here also the object was moving in the opposite direction as the force, therefore the word that was used was against. Now let's do part C. Part C says find the work done by the push force. Now, be a little careful over here. Can I say that the work done by the push force is 30 multiplied by 3? Can I say that? Yes or no? Considering, why not? Considering कि जो push force है वो ऐसे act कर रही है. This is the 30 Newton force. No, not because of friction. Not because of friction. It is not because of friction. We can't say that. It's some other reason. Okay, and Anaf, can you elaborate what that reason is? I think you've gotten it right. You've figured it out. Can you please elaborate what that reason is? Why can we not do 30 times 3? Because force is in horizontal surface. That's correct. Remember, the rule is that when you're taking force, when you're finding out work done and you're doing force times distance, the two forces must be parallel. Okay, so if the distance is horizontal, the force must also be horizontal. So no problem. No problem. We can always resolve. We're given the angle, right? We're given the angle to the horizontal to which the force acts. Now, I've deliberately drawn it on a horizontal surface just so that we can pay attention to this part, okay? So irrespective of whether it's on an inclined plane or not, we're just taking the fact into consideration that the force is acting at an angle and the distance is moving parallel to the plane. Okay, so I've just ignored the inclined plane altogether. So this is 10. There will be a horizontal component, which would be 30 cos 10. Okay, and that is what we will multiply by the distance. So 30 cos 10 multiplied by the distance. What's that equal to? Let's work it out. 30 cos 10 multiplied by the distance, which is equal to 3. And that is equal to 88.63. Okay, that's equal to 88.63 or 88.6 joules. Okay. Now find the work done by the normal reaction force. Okay, see if you guys can answer this question. This is the normal reaction force, and we need to find out the work done by this force. What do you think will be the work done by the normal reaction force? Put some thought into it and then answer. What do you think will be the work done by the normal reaction force? Remember the same concept, force times distance. The force is R. We can always work out what the force is. And then we need to multiply that by the distance. So what do you think that's going to be equal to? Put some thought into it. I'd appreciate a response from you guys. Don't just be spectators. $130 joules. Okay, I'm curious to know where that came from. 130 joules. So I'm assuming you've taken the normal reaction force and multiplied that by the distance. 50 cos 30. Okay. The answer is not 130. Okay. So here's the answer. The normal reaction forces are, we can always work that out. Okay. The question is, what's the distance the object has moved in this direction? What's the distance the object has moved in the direction that's perpendicular to the plane? Has the object moved at all in the direction that is perpendicular to the plane? Because it's sliding along the plane. Okay, so if an object, let me see if I can find something to explain the concept. So if an object here, so here's an object. Okay, I hope you guys can see. The object is moving parallel to the plane. Has it moved perpendicular to the plane at all? So this is this is the direction in which the normal reaction force is acting. Has the object moved in the direction the normal reaction force is acting? Yes, no. If it's moving parallel to the plane, no, it doesn't. Okay, it stays on the plane. It's not moving in the direction of the normal reaction force, meaning the perpendicular distance from the plane is not changing. If you think about it, it's on the plane. So the perpendicular distance from the plane remains zero. No matter where this object moves, the perpendicular distance from the plane remains zero. So therefore, the answer to work done by the normal reaction force will simply be equal to zero. Okay, the answer to part D is simply equal to 0 joules. Why is that? That's because work done is equals to force times distance. Now, whatever the force may be, the distance remains 0. Why? Because the object is the perpendicular distance of the object, from the plane is 0. Okay, so I hope this concept is clear. Now, the final part, and then I'll give you guys a question to solve. The final part is the total work done. Okay, now remember, to find out the total work done, we use a formula. The total work done is simply by minus against. Okay, and I'll explain what I mean by this. I can explain. Can you explain? Okay, so I'll explain. Now imagine that this is the direction in which, actually, this is not something you have to imagine. This is the direction in which the friction is acting. Now imagine that the object doesn't move. It stays here. Okay, so imagine this doesn't happen. Then if I ask you, what is the work done by the frictional force? What are you going to say? The frictional force is of 2 newtons, okay, but the object hasn't moved. So that means the direction in which we're supposed to find out the work done, the object doesn't move in that direction. Correct? So the answer would simply be 0. Make sense? Okay, now, just like that, if you're supposed to find out the work done by the normal reaction force, at any point, has the perpendicular distance of the object changed from the plane? ऐसा तो नहीं हुआ ना कि ऑब्जेक्ट यहाँ पे आ गया, मैं कहूँ कि ओ जिस डायरेक्शन में नॉर्मल रिएक्शन फोर्स एक्ट कर रही है उस डायरेक्शन में ऑब्जेक्ट ने मूव किया. I can't say that. At no point does the perpendicular distance of the object from the plane changes. Why? Because this object, like I said, this object does not move in this direction. Okay, the direction in which it's moving is up and down the plane, parallel to the plane, not perpendicular to the plane. Okay, so because the object is not moving in the direction the normal reaction force is acting, therefore the distance is 0, and therefore the work done is 0. Okay. All right. By indicating positive direction, I don't know what you mean by that. Or I don't know what is that. Is that related to this that you're asking, Tanveer? If yes, then hold on. So basically, total work done is equal to by minus against. What do I mean by that? That means you take all the forces where you see the word by. Okay. So we see the word by with push force. What's the work done by the push force? I think we worked it out. Work done by the push force is 88.6. So that is 88.6 minus the work done by all the forces acting in the opposite direction. Okay, opposite direction in which the object is moving, which we know is the work done by the work done against friction and the work done against gravity, which was 75. Okay, so what's by and what's against? This is what we mean by and against. Okay, by means the object is moving in the same direction as the force. Against means that the object is moving in the opposite direction to which the force is acting. So this is how we find out work done, the total work done. So 88.6 plus 6 plus 75. So this will be equal to 7.6 joules. That is the total work done. Okay, now I want you, as always, to take a good look at it. I will give you guys a question to solve, and we'll do some past paper questions today as well. But in the meantime, if you have any questions, please let me know. Solve this question and let me know what your answer is. I'll quickly solve this question and then we will start a new concept, which is work energy principle. So here's how this works. Pay close attention. Work done against friction. So a good idea is always to visualize the situation that you're in. So you have a box which is pulled 2 meters across a horizontal floor using a rope with tension 10 newtons at 30 degrees to the horizontal. So that means this is how it's being pulled. This is the tension acting away, and the angle that it's making with the horizontal is 30 degrees. So here it is. This is 30 degrees. ठीक हो गया? अच्छा. Now you're pulling it 2 meters. So that means it moves from here to here. Now the work done against friction, once again, notice that the word that is used is against. Okay. But once we're done with the concept, once we're in a position to do past paper question, of course, we'll do past paper questions as well. Okay, so is this your first class today, Tanveer? Work done is equals to force times distance. What's the force? The force is 3 newtons. Okay, and what's the distance? The distance is 2. So what's 3 times 2? 3 times 2 is equals to 6 newtons. So this is the work done against friction. Now part B. Part B is the work done by tension. Now, in order to find out the work done by tension, notice that the object is moving horizontally. So yes, we will do work done into equals to force times distance, except that the component of force that we will take will be the horizontal component, and we'll multiply that by the distance to get the true work done. So the work done is equal to whatever this turns out to be, I think 17 point something. So 17.3 joules is, I think, the correct answer. Then the work done by the weight. Now, is the object moving in this direction or in this direction? Is the object moving vertically, which is the direction in which the weight acts? No, so therefore it's 0. Then the work done by the normal contact force. Once again, because the object is not moving vertically, the work done by the normal contact force is also 0. Then the question says the total work done by all 4 forces. So the total work done by all 4 forces will be equal to, we're going to add them up. And remember, by minus against. So total work done is equal to by minus against. So the work done by the force, by the tension, that's 17.3 minus the work that is done against. So 6 joules. Yeah, 6 joules. Sorry, I end up writing it as Newton. So 17.3 minus 6. Let's see what that is. 17.3 minus 6. That's equal to 11.3. That's correct. So 11.3 joules is the answer. Okay, so that was just the basic idea of work done. Yes, total work done implies the net work done. That's correct. Total work, because we subtract the work done against from the work done that's from the work done by the forces. Therefore, that is basically the net work done. Okay. Now, we are now going to start not a new concept, but basically we're just going to take this to the next level. Okay, so notice that here there are no external forces acting. There is no concept of energy over here. It's just basically work done. So now what we're going to do is something known as the work energy principle. So here it is. Work energy principle. Now, there are 2 approaches to solving questions that deal with work energy principle. Okay, and we're going to look at both the approaches. First, we're going to look at, in today's class, I think we're just going to stick to the first approach. Okay, and in the next class, inshallah, we're going to look into the other way of approaching this question as well. So approach 1 is that the total work done is equal to the change in kinetic energy plus the change in potential energy. Okay, so that's one way to solve questions using work energy principle. So just a minute, let me I write this nicely. So here's approach number 1. Okay. And what's that equal to? This is what it's equal to. Total work done is equals to change in kinetic energy plus change in potential energy. And since we're talking about change, remember, it can be positive, it can be negative as well. Like, for example, how do we calculate change in kinetic energy? This is how we calculate change in kinetic energy. It's going to be half into m into v square minus u square. That means the velocity after minus the velocity before. And just like that, how do we calculate the change in potential energy? It's going to be mgh. mg, and the height would be the height after minus the height before, meaning that if the object is moving from point A to point B, the height at the end minus the height initially. And this is equal to total work done, which means by minus against. Okay, so this is basically what the work energy principle is. And with the help of this, we're going to be solving some questions. So we'll start with some easy questions and then gradually increase the difficulty level. So here I have a fairly easy question. It's a past paper question, which we're going to solve using the work energy principle. Now, sometimes you will notice that the question will explicitly ask you to use the work energy principle. Sometimes it won't. So if it explicitly asks you, then you have to use the work energy principle. If it doesn't, then it's up to you. So here it is. Here's a past paper question, which we're going to solve together. Let's see what it says. So it says a crate C is pulled up at a constant speed up a straight inclined path by a constant force of magnitude F newtons acting upwards at an angle of 15 degrees to the path. C passes through the points P and Q, which are 100 meters apart. All right. As C travels from P to Q, the work done against resistance to C's motion is 900 joules. So the work done against the motion is 900 joules. Okay, so we need this. We're going to use this shortly. And the gain in potential energy is 2100. So that means this is a positive change. Okay. Write down the work done by the pulling force as C travels from P to Q and hence find the value of F. Okay. Now, another very important keyword in this is that the constant speed is constant. Now, what do you think will be the change in kinetic energy if speed is constant? What do you think? If speed is constant, what do you think is the change in kinetic energy? I'm not asking for the kinetic energy. I'm asking for the change in kinetic energy. Okay, there will be definitely a kinetic energy, but there will be no change in kinetic energy. Okay, so remember, if the object is moving horizontally, that means there is no change in kinetic energy. If the object is moving at a constant speed, that means there is no change in kinetic energy. Okay, so I'll write this down. These are important notes. Note number 1. If the object is moving at a constant speed, there will be no change in kinetic energy. Okay, makes sense. Similarly, if the object is moving horizontally, okay, if the object is moving horizontally, there will once again be no change in potential energy. Why? Because there is no change in height, therefore no change in potential energy. ठीक हो गया? Okay, now let's solve this question. So we are going to use the work energy principle. What is the work energy principle? This is what the work energy principle says, that the total work done is equal to the change in kinetic energy plus the change in potential energy. Now remember, when we say total work done, we do by minus against. Okay. Now by is basically the work done by the F Newton force. So do we have that? No, we don't. So what's the work done by the force? We don't know. In fact, that's exactly what we're supposed to calculate. What's the work done against resistance? We have that. That's 900 joules. Okay. What is the change in kinetic energy? There is no change in kinetic energy because it's moving at a constant speed. However, what's the change in potential energy? That's equal to 2100 joules. Okay, what's that equal to? That's equal to 2100 joules. So what we can do now is we can solve this equation and we can calculate the work done by which force? By the F Newton force, because that's the only force that's acting in the direction the object is moving. So what's the work done by the F Newton force? That's equal to 3000 joules. Now the question is, how will I calculate the value of F? How will I work out the value of F? We know very well that work done is equals to force times distance. Okay, the work done is equals to force times distance. Now, F is not basically in the direction the object is moving. Okay, F Newton is not the direction in which the object is moving. The object is moving parallel to the plane and it moves 100 meters parallel to the plane. And we want the component which is parallel to the plane as well. And what's that going to be? Since the angle is 15 degrees, that means the component of the F Newton force, which is parallel to the plane, will be equal to F cos 15. That is the force multiplied by the distance, which is equal to 100. That will give us the work done. And what's that equal to? That's equal to 3000. Okay, so I repeat, although we do have the work done, okay, we do have the work done by the F Newton force, but the question is, how will we use that to calculate the value of F? Well, if we were to, let's say, calculate the work done by the F Newton force, what would we do? We would take the force, which is acting in the direction the object is moving, and we'd multiply that by the distance. So this is what we would do. And we already have the work done. We already have the answer to this. So that means we can now use this equation to calculate the value of F. And let's see what that is equal to. 3000 divided by 100 divided by cos 15. And that's equal to 31.05. So we're going to write this as 31.1. So F is equals to 31.1. That's the answer. Now, I want you guys to, as always, take a good look at it. Let me know if you have any questions. Just remember the formula. Total work done is equal to change in potential energy minus change in plus the change in kinetic energy, and total work done is basically by minus against. Simple. Okay. So I would like you guys to try and solve the following question. Okay, just do the first part. And I hope you guys know that kilo means 1000. Okay, so if the question says 1 kilojoules, 1 kilojoules is equal to 1000 joules. Okay, so this is a unit of conversion that you all must know. So try and solve this question. And when you have the answer, do share it with me. So a lorry of mass 12,500 kg travels along a road that has a straight horizontal section AB and a straight inclined section BC. The length of BC is 500 meters. The speeds of the lorry at A, B, and C are 17, 25, and 17 respectively. Okay. Find the work done against resistance to the motion of the lorry as it travels from A to B is 5,000. Find the work done by the driving force as the lorry travels from A to B. Now, every time there's an engine involved, okay, there's got to be a driving force. Okay, so every time, let's say we're talking about a car, we're talking about a truck, we're talking about a train, there's got to be a driving force. Okay, so what's the formula? The formula for total work done is equals to change in kinetic energy plus the change in potential energy. Now, what is the total work done? Total work done means by minus against. Basically, all the work done by the forces that are acting in the direction the object is moving minus the work done by the forces that are acting in the opposite direction. Okay, equals to change in kinetic energy plus the change in potential energy. Now, the work done by is basically the work done by the driving force, okay, which we don't have. So we'll leave that as it is. Okay, so I'm going to put a bracket. I'm going to, in the bracket, write df to show that the force which is acting in the direction the object is moving is the driving force. Minus against. So against is the 5,000. The work done against the resistance is the 5,000 joules that were given, except that it's not 5,000. It's 5 100,000. Sorry, 5 million. Yeah, it's 5 million joules. Okay, because it's already 5,000, so 5,000 times, that's 5 million. Okay. Acha, then what you could, so either keep everything in joules or everything in kilojoules. Okay, so I'm just going to keep everything in joules. Is equal to change in kinetic energy. Will there be a change in kinetic energy? Definitely there will be a change in kinetic energy because there is a change in speed. So 25 squared minus 17 squared. Will there be a change in potential energy? No, because the object from A to B is horizontal. So the track from A to B is horizontal. Therefore, there is no change in potential energy. Now let's solve. So the work done by the driving force will be equal to, let's see what do we get. 0.5 or half divide by into 12,500. So half into 12,500 into 25 squared. Make sure that you work it out the way that you see it. Okay. That is that you put 25 squared minus 17 squared inside the bracket. So we get a huge value. In that, I'm going to add 5 million. So what we are looking at is 7, 1, and how many zeros? 1, 2, 3, 4, 5. So 5 zeros. So this is what I'm looking at. 7, 1, 1, 2, 3, 4, 5. So 7,100,000 joules. Or if you divide this by 1,000, we get 7,100 kilojoules. There you go. Okay, so not complicated. Although the questions that we're solving right now are not too difficult, but overall, this concept is not that complicated given that you know exactly the formula that you have to use and you basically have to get familiar with this formula. Okay, it's a very magical formula and it's going to solve most of our problems. Now I'm going to do part 2 and I want you guys to pay close attention. Yeah, in fact, let's keep the same approach. You guys can use the working for part 1. I'm going to give you 4 minutes to work out part 2. See if you can do it. If you can, that's great. If not, then I will solve. Okay, same formula. We'll use the same formula. The only difference is that there will be a change in potential energy as well. There will be a loss in kinetic energy and there will be a gain in potential energy. Now, what will that gain be equal to? That I want you guys to figure it out yourself. So when you have the answer, please do let me know. So here's how it works. Same formula. Okay, nothing changes. Total work done is equals to change in kinetic energy plus the change in potential energy. Just know that there will be a loss in kinetic energy and there will be a change in potential energy. Why? Because the height increases and the speed decreases. So how do you find out the total work done? Let's read the question. As the lorry travels from B to C, the resistance to motion is 4,800. Okay. And the work done by the driving force is 3,300 kilojoules. So that means when we're doing by minus against, we already have the work done by the driving force, which is 3,300,000. Okay. Minus the work done but against resistance. Now, how do you calculate work done? If you're not given, since we're given the force, we're given the distance, so we can simply multiply the two. Okay, so the force is 4,800 and the distance, just make sure they're both in the same direction. Yes, they are. So there is a constant resistance to motion. So this is the constant resistance to motion. This is the direction in which the object is moving. So they're both in the same direction. That means we can multiply the two. Yes, Meetup 24 is the final answer. Good job. If you've gotten it correct, good job. That means you've understood the concept. So 4,800 multiplied by 500. Okay, equals to change in kinetic energy. Now, what would be the change in kinetic energy? It's going to be half times 12,500 times the final velocity, which is 17 squared minus the initial velocity, which is 25 squared, plus the change in potential energy. Now, what will be the change in potential energy? The change in potential energy will be mgh, and that's it. What you're supposed to solve is for the value of h. Okay, everything else is pretty straightforward. Okay, so let's solve. Let's see what do we get. So let's work this out. 4,800 into 500, 3,300, 3 zeros minus answer. So we're looking at 900,000. So 900,000 is equal to 0.5 into 12,500 into 17 squared minus 25 squared. Close the bracket. So This is minus 2, 1, and how many zeros? 5 zeros. Okay. 1, 2, 3, 4, 5. 2, 3, 4, 5. Plus 125,000 H. Okay. So 21 and 1, 2, 3, 4, 5 and 6 zeros plus 9 and 5 zeros. So 9, 10 power 5. So I'm looking at a certain value, which I'm going to divide by 125,000. And we get the value of H, which is equal to what? Which is equal to 24 meters. There you go. Okay, so a lot of working, yes, but this is how it's supposed to be done. Okay. So if you guys have any questions, please feel free to ask. 33. अच्छा, just a minute. I think मैंने भी कुछ calculation में गड़बड़ कर दी. Because I'm not getting, although the working is the same, but my answer is not matching. So I've probably missed a zero or something. एक काम करते हैं. Here's what I would suggest. When you have such significantly large values, let's keep this in kilojoules only. Okay, so let's keep this in kilojoules. So it's 3,300 kilojoules. 3,300 kilojoules. Let's divide this by 1,000 as well. Okay, let's divide this by 1,000 as well. Let's divide this by 1,000 as well. So everything is in kilojoules. Okay, so 3,300 minus, let's work this out, 4,800 into 500 divided by 1,000. So that's 2,400 is equal to, let's work this out, 0.5 into 12,500 into 17 squared minus 25 squared. Let's close the bracket, divide by 1,000. So that's minus 2,100 plus, so we cross out the 3 zeros, 125 H. Yeah, I think now we're good. So 3,300 minus 2,400, that's 900 plus 2,100, that's 3,000. So 3,000 kilojoules is equals to 125 H. Let's divide 3,000 by 125. And now we're getting the correct answer, which is 24 meters.